moving on with chapter 3, this properties of logs. And oh geez, what's going on here? Stop that. Ha! Hey, we're going to use different properties of logs to kind of simplify log problems in general. Here's a quick review of some properties of exponents. And the reason I'm showing you this is because it ties into the properties of logs. But if you remember, if you multiply two things with the same base, you add the exponents, and that would be something like x squared times x to the fifth. You just know that that's x to the seventh. You add the exponents. If you are dividing, you subtract exponents. So if I had x to the fifth over x squared, you can do x to the 5 minus 2, which gives you x cubed. Although you usually don't think of it like that, you probably normally think of it as, I'll just cancel 2 of these x's with 2 of those and leave 3, which is essentially the same thing. And then the last one, x to the a to the b. If you have something raised to another power, you multiply the exponents. And that kind of thinking, where multiplication translates to addition, division translates into subtraction, moves into your properties of logs. And these are your 6 basic properties of logs. And I say 6, but really it's just these first 4 that are the big ones. Because numbers 5 and 6, while they are true and good for you to know, those are things that you could figure out even if you did forget those properties. But if you have a log, regardless of the base, and you're multiplying inside the log, you split that up with addition. Just like with these exponents, if you're multiplying two things of the same base, you split it, or you combine it with addition. So multiplication in a log translates to addition. Division in a log is split up with subtraction. Log of x minus log of b, just like dividing with exponents is subtraction. And then if you have an exponent on the log base b of x to the n, you can actually grab that exponent and move it down front as a coefficient. And those are the ones we're going to use to simplify stuff. This one right here, the change of base formula, that's what this one's called, number 4, is called the change of base. This is used for calculators if you needed to plug a log into the calculator. So let's say I wanted you to find the log base 2 of 7 in the calculator, but the problem with your calculator is you only have a log button and you have an ln button. You don't have log base 2. So the way you would do log base 2 of 7 is you would do it as, and you keep the base the same. I usually will use natural logs. I wrote log base c, but it would be the natural log of a over the natural log of b, a and b. In this case, that would be 7 and 2. And actually, I think I may just change that right here. While I'm thinking about it, instead of log base c, while that's true, we can make it a little bit simpler and say that log base b of a is the same thing as the natural log of a over the natural log of b. Maybe that'll be a little bit easier. All right, so using these properties, what I want to do is split these logs into the sum or difference of a bunch of other logs using these main 4 properties right here. So if I have log base 4 of x squared times y, well, this is multiplication, and multiplication, I remember, is split up with addition. So that's going to be log base 4 of x squared plus log base 4 of y. And I would appreciate it if you would stick whatever's in the log in parentheses. Let's see, I'm almost done here. I did split it up into addition, but then the last thing I want to do is I see an exponent. I want to pull this exponent down in front of the log, and I'm going to write it as, instead of log base 4 of x squared, I'm going to write it as 2 log base 4 of x plus log base 4 of y. And that would be how we separate it. See, moving on to number 2, this is a natural log, but it doesn't matter. I see a to the 4th times b divided by c cubed. So the multiplication is split up with addition. So ln of a to the 4th plus ln of b. But then I'm dividing by c cubed, so minus the ln of c cubed. And then I need to take those exponents and move them down front. So instead of having the ln of a to the fourth, that's going to be 4 ln a. And for c cubed, that's going to be 3 ln c. So 4 natural log of a plus natural log of b minus 3 natural log of c. Multiplication is split with addition. When I was dividing by c cubed, we subtracted and then we pulled our exponents down. Let's look at number 3 here. Log of x times y. Well, that's multiplication, so I will split that with, it's not a natural log, so I'll split that with addition. So that's log of x plus log of the square root of y. And that may look like we're done, but the square root of something, if you remember way back in the day in Algebra 1, you learned that the square root of something is the same thing as that thing to the 1/2 power. So when I see a square root, that's actually an exponent, where you could change that. Instead of reading it as the square root of y, we could read that as y to the 1/2 power. And if you have an exponent, I'm going to expect you to grab the exponent and move it down in front as a coefficient. So I'll finish this problem by writing it as log of x plus, I was multiplying, so plus, and then I brought the 1/2 down, log of y. Okay. Multiplication turns into addition. Exponents come down. Let's see, I think there were a couple more on this one. Here, this one's a little bit tricky. I see the cubed root of x squared. I'm going to go ahead, well, we'll tackle this in a couple of steps. It's log base 2. So I see log base 2 of the cubed root of x squared. And then on bottom, I have y squared times z. Now, what most people are going to want to do is they'll say, okay, I'm dividing by y squared, so they'll say log base 2 of y squared. But then they'll see, okay, well, it's y squared times z, so they want to say plus log base 2 of z, which makes sense because you see that multiplication, but it's not addition. It's actually going to be minus log base 2 of z because that z is still in the denominator. We are dividing by the z, and anything that's in the denominator is subtracted. So even though it is y times z in the bottom, I am still dividing by y squared and z. So it's going to be minus log 2 of y squared minus log 2 of z. Then I have to take care of the exponents. Well, the easy exponent is going to be my y squared. That 2 is going to come down like this. The one that's not so easy is the cubed root of x squared. So we're going to have to kind of think a little bit about the cubed root of x squared. If you can remember, that's the same thing as x to the 2/3 power. So the cubed root of x squared is the same thing as x to the 2/3, which means I'm going to grab all of this, the cubed root of x squared, that's kind of like my exponent, and I'm going to move it down front as 2/3, because that was the exponent, log base 2 of x, minus 2 log base 2 of y, minus log base 2 of z. Good? Good? All right, I think, is there one more, or is there one after this? Yeah. All right, so number 5 here, it's a natural log of, I see x cubed, ln of x cubed. And then I'm dividing by all of this. All of this is divided by something, so it's all going to be minus. So minus, I have a y, minus, and then I have a z plus 1. And make sure you keep that z plus 1 together. Anything that's in the denominator is subtracted when you split this thing up. Then we will grab that x cubed, take that exponent, we're going to move it down front. So 3 ln of x minus the ln of y minus the ln. Z plus 1 cannot be split up. You only split up a log if it's multiplication, and plus 1 is not multiplication, that's addition. So this is going to be my final answer for number 5. You good? You're good? All right. Going in the reverse direction, instead of expanding logs, let's see if we can condense them, write it as one big log expression. So we're going to go in the exact opposite order. So the first thing we're going to do, any coefficients, I'm going to grab them, and we're actually going to stick them back inside the log. 1/3. I'm going to grab that, move it back inside the log. So my first step is to write this as log base 3 of x to the 4th minus log base 3 of, and then it's x plus 6 all to the 1/3 power. So now I've gotten my exponents up. I've pulled my coefficients up as exponents. Now I need to combine these two as one log. So log base 3 of, it's x to the 4th minus log of that. That's going to be division. So it's going to be x to the 4th divided by x plus 6 to the 1/3. And I am okay with this answer. If you want to stop right here, some of y'all may be thinking, well, if you raise something to the 1/3 power, that's the same thing as the cubed root. So some of y'all may want to write it as x to the 4th over the cubed root of x plus 6. Either one is perfectly fine. I don't really have one preference over the other. I'm perfectly okay with an exponent of 1/3. Let's see, how are we doing on time? 11 minutes. Let's see. 6 ln of x minus 3 plus ln of x. Let's see, I'm wanting to combine these. So first I'm going to take any coefficients, and they're going to go inside my log. Whoops. Go inside my log. So I'll first write this as the natural log of x minus 3 all cubed, or all to the 6th power, plus natural log of x to the 3rd. So now that I've gotten rid of my coefficients, then we look at it and I think, let's see, we're adding two logs, and if you're adding two logs, you combine them with multiplication. So it's going to be x minus 3 all to the 6 times x cubed. So there's our answer for number 2. Let's see, number 3. Number 3 here. This has a lot going on. Number 3 has a lot going on here. I do see one coefficient. I see this x to the, or this 4, so I'm going to bring that up and make it x to the 4th. Let's see, so let me do that real quick. Okay, there we go. So I brought that up. Now I need to combine all of this into one log. I've gotten rid of my coefficients, so now I'm going to write this as just one big honkin' natural log. And let's see, it's ln of 3 plus x minus ln of x to the 4th, so that's going to be division. So 3 plus x minus x to the 4th means divided by x to the 4th. Then minus ln x minus 1. Since I'm subtracting, that means the x minus 1 goes in the denominator also. Anything that's positive goes on top. Any negative log means you're going to stick that part in the bottom, and this is going to be how we condense number 3. Here's our answer for number 2. Good. Okay, evaluating in a calculator. These are extremely easy, and these are playing off that change of base rule. There is no log base 3 button in the calculator. All right, and the change of base formula is, let's see, it's log 3 of 10. I would evaluate that by doing the natural log of 10 divided by the natural log of 3, and we're just going to throw this in the calculator. So let me go to my calculator here. Whoops, yeah, here it is. So here's my calculator, and I'm going to do, what was it again? The natural log of 10 over the natural log of 3, and so I'll just punch in ln of 10 divided by the natural log of 3, and I'm doing this on an 89. You 84s, there's an ln button, there's also a log button, you can do either one. And if I hit enter, the calculator just tells me this. The way I get my decimal answer is you hit the green diamond, and see my little green diamond showing up right here. I hit green diamond and enter, and that gives me the decimal, and we get 2.09, and I like to round to the 3rd decimal, so 2.096. This is approximately 2.096. So number 2, I'm going to do the exact same thing. Log base 1/2 of 12 is going to be the natural log of 12 over the natural log of 1/2. And we'll just go to the calculator and plug that in. ln 12 over ln 1/2. ln 12 divided by ln 1/2. Green diamond to get the decimal, enter, and you get negative 3.585 is how I'm going to round that. So negative 3.585, and that's an approximation, so I'll put the approximate symbol. Good, good? Good, 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 good. All right, and the very last thing, we're at 15 minutes. This is about normal for me. Write the following logs in terms of natural log of 2 and natural log of 5. Well, that means I have to convert all of these numbers to where they're related to only 2s and 5s. Well, 5 isn't a problem, but 8, we've got to think about how does 8 relate to 2, and I'm thinking in my head over here, well, I know that 8 is 2 cubed. So I'm going to change this, instead of ln of 8/5, I'm going to change it to the ln of 2 cubed over 5. And then I'm going to use my properties of logs to split this up. I'm dividing, so if I'm dividing inside a log, that's going to be the ln of 2 cubed minus the ln of 5. You split it with subtraction if you're dividing. And then my 3 is going to come down front, so that's going to be 3 natural log 2 minus natural log 5. And that'll be your answer. So that's what I mean by write it in terms of 2 and 5. You just have to convert the numbers into 2s and 5s. Ln of 100, so okay, I've got to think about what I can do with 100. Let's see, I know 100 is 4 times 25, right? Now 4, I know that 4 is 2 squared, and I also know that 25 is 5 squared. Well, those are 2s and 5s, and that's what I want. So I'm going to change 100 into 2 squared times 5 squared. Okay, well, now I'm multiplying inside of logs. That's going to be ln of 2 squared. If you're multiplying, it becomes ln of 5 squared. And then I'll bring the exponents down. 2 ln 2 plus 2 ln 5. You're good? You're good? Seeing how that works? Seeing how that works? I think there's only one more, and then we'll call it a day. ln of 3.2. Well, 3.2 I'm not a fan of. I know 0.2 is 1/5, right? So 3.2, I'm going to change to 3 1/5. Good, good? And if you didn't know if you didn't know that 0.2 is 1/5, 0.2 is the same as 2/10, which reduces to 1/5. And 3 1/5, 3 times 5 is 15, plus 1 is 16. So that's 16 over 5. So ln is 16 over 5. And then I have to convert 16 and 5 into 2s and 5s. Well, 5 is not a problem, because 16 is 2 to the 4th. And now I can split that up. ln of 2 to the 4th minus ln of 5. 4 natural log 2 minus natural log 5. Bring down that 4, and there we go. I've had enough.